Thank you guys for waiting, and we're gonna have this panel start soon. And by the way, after this one, we have a very special session. So stay tuned. After this, I will announce what we're going to talk about. Thank you. Alex, please.
Good late morning, everyone, and thank you for joining us today for the AI and Web3 panel. I'm Alex. Felix, co-founder and CIO of Coinfund, one of the oldest crypto funds, founded back in 2015, that's been focused on the space at large. Really excited to be here. Big thanks to Harvard for putting together all the resources to pull this off, to really educate sort of the up-and-coming minds around why crypto is important and also what's so exciting about it. I'm pleased to have some of the top experts in the space with me today, so I'm going to kind of yield to them, and we're all going to try to learn together today. Good to see you, Harry. And thank you to all the sponsors that also made this possible and got everyone together. So really looking forward to our panel. I think at a high level, what I want to establish today is, as the Web3 movement grows, people are always very critical of what are the use cases. And when we unpack some of the challenges and exciting opportunities around AI, we might come to the conclusion that AI needs Web3 more than Web3 needs AI. There's a real validating use case here that will hopefully, if you believe in free markets, bring back openness to a sector that's getting dominated currently by incumbents who own a lot of compute resources. When we think about what is compute, it's sort of emerging as one of the biggest commodities of our decade, and is poised to play a major role in the future of software and the future of learning. And so, without further ado, I want to let the panelists introduce themselves, and we'll get into it. Maybe I'll kick it over to Harry. Do you want to say hi first, and then we'll go down the row?
Hi, everyone. I'm Harry. I'm the co-founder of Nesa.ai, and I've been doing AI at Meta, and before that, I was PhD at USC. Great to be here today. Thanks.
Hey everyone, I'm Ben. I'm the co-founder of Gensyn. We're a machine learning compute protocol. So like Alex was saying, we essentially provide a much more free market over the compute resources that sit underneath AI. So the chips, GPUs, TPUs, CPUs, anything that's capable of doing machine learning training. Prior to Gensyn, I did a PhD in deep learning, and I also had a startup in the data privacy space. So feel pretty strongly about individual kind of consumer privacy rights as well.
Hey everyone, my name is Lukas. I'm part of the founding team and heading up the ecosystem of Nillion. Previous to that, I went to Cambridge University, so actually the Cambridge in the UK, not the Cambridge here. I've spent the last 2.5 years at Nillion. What are we doing at Nillion? Nillion is a public decentralized network for private compute and private storage, utilizing different privacy-enhancing technologies to do so, specifically multi-party computation, MPC, AG homomorphic encryption, and others, with the essential vision being to decentralize trust for high-value data, sensitive, important information that you don't necessarily want to put in plain text on a blockchain, that you don't necessarily want to store and process in plain text with a cloud provider, but instead in a decentralized network that can actually decentralize the trust and disintermediate actors. Obviously, there are potential implications for that in the AI space, which we'll talk about today, but the potential opportunities and use cases for technology like that span obviously way beyond that into finance, into healthcare, supply chain, and many others.
Hi everyone, I'm Sishir from Spectral. So we have been building an LLM that generates solidity code from natural language. And so the purpose of that is really to kind of create this agent economy on-chain. So the equivalent of like GPTs in Web 2, but you can think of like on-chain agents having access to their own wallets and to their own private keys, being able to sign permissions and transactions on their own, and essentially act autonomously. Prior to this, I was on the venture side in crypto, and just been in the space since around 2014.
Thank you all. And for the format today, we'll spend on some of the questions, we'll all get your varying opinions because this is a complex topic, and on some, feel free to, take the mic or wait for the next question. Where we should start is, what problem does Web3 solve for AI? Sort of why do we need it, and what's your thesis for how the market starts to develop?
So the way I like to look at this really from an holistic perspective is, what does crypto do, right? Crypto exists to decentralize trust, and crypto exists to disintermediate actors. And I think we succeeded in doing that for a store of value with Bitcoin, for programmability more broadly with Ethereum, based on key principles like open global participation, censorship resistance, and collaboration. And I think today we are at a very similar junction with AI, right? We have to trust and rely on a few very, very powerful actors, right? Who are very concentrated, very centralized, for things like compute supply, right? Where they can essentially, or where they currently hold the vast majority of compute supply in their hands and can, as a consequence, charge a significant economic premium on that. But also for things like training models, running inference models. Right now, whenever we submit a prompt or train those models, we submit our personal, sensitive, high-value data to these companies, and we have to trust them that they don't misuse it. We have to trust them that they don't share it. We have to trust them that they don't sell it and exploit it. And I think this is where crypto comes in, coming back to how I started, decentralizing trust and disintermediation. I think there are a couple of really exciting points for which decentralized infrastructure can be helpful for. The first one is on the compute side. Right now, as I said, it's very concentrated, but marketplaces can potentially reduce costs, introduce more flexible pricing, censorship resistance, those great things. On the data side, data right now is very centralized. It sits in silos. It's not portable. It's not composable. It doesn't really get shared. And that means that enterprises lose out on a tremendous amount of potential value creation. And on the retail and user side, we collect all this data across all these different sources, from social, browsing, location data, but we don't actually contextualize and harmonize the data as well as we could. I think here, decentralized infrastructures and privacy-enhancing technologies specifically, like multi-party computation, fully homomorphic encryption and the likes, will be incredible value adds to enable data sharing and thus enabling portable models, portable data, to essentially create a really personalized future where people can earn on their data and likewise become self-sovereign owners of their data. And last but not least, what I'm excited about as well when it comes to crypto helping out is talent, right? Talent right now is still flooding into decentralized companies, and that makes sense. It's very hard for open developers, open source developers to capture economic value. But again, crypto shines whenever there's a coordination challenge. Crypto shines whenever there is an incentive challenge. Crypto shines whenever there's a censorship resistance challenge. Here, crypto can help developers to earn, monetize some of the open source developments they do, and really create this equitable future where people can participate globally on building things together, right? So in summary, I'm excited about essentially crypto stepping in whenever we have those centralization challenges to fundamentally open up grounds for innovation. We are stronger together, right? That's very much the crypto ethos that we started with. And I think particularly in this intersection, it is more true than ever before.
Yeah, I'll add to that. I think that data provenance you mentioned is like really critical piece. Another thing I'm super excited about is actually a medium of exchange. And so if we wanted kind of a natively digital medium of exchange, you wouldn't expect an agent or an AI model to wire transfer or walk into a bank and open an account. And so crypto and Web3 allows these kind of native primitives that AI and agents would actually expect to have. And I think that exchange level and that medium of exchange is actually quite powerful, especially when we kind of evolve into agents interacting with each other. And so this like kind of underlying foundational like infrastructure that we're building will need Web3 native currencies to actually start transacting and actually really doing these things that we kind of picture in the future.
I totally agree with that. We think about that future of ubiquitous machine learning a lot, where as a tool, as a technology, it generally makes a lot of the tech that we use right now just better. You can see it as a kind of general purpose just uplift in the technical tools that we have. But for that uplift to happen across the entire world, the resources underneath it need to get much easier to access and much more programmatic. Right now, if you want to train a machine learning model or run inference or something like that, you're going to have to get access to various things, compute, data, expert knowledge in designing the models, etc. All of those things right now, you have to go through the human world. So you have to have a contract with a company that does it, you've got to have SLAs, you need to put infrastructure in place, you need people selling it, etc. That means that a model that wants to access any of those resources can't do it because it has to have a person attached to it. But Web3 technologies give us that programmatic access. You can expand the environment that those autonomous agents exist within, away from just financial and smart contracts, to compute, to data, to expert knowledge. They can incentivize people to design new models and things like that. So it's essentially empowering machine learning itself to be as effective as it can be, as fast as it can be. Whereas if we keep the current status quo, where companies are sitting on top of these resources and essentially rent-seeking, then we just leave a limiter on human progress, essentially. We just do much slower progress within machine learning, and it slows down everything we do if you view it as a technology that unlocks basically everything. We view it as the next technical revolution, essentially, and we should do that as fast as we can.
Yeah, I think those are very good points. I think at Nesa, we are layer one infrastructure for AI, and we're doing distributed inference. And I think we solve a lot of challenges in this domain, like how to make this compute more accessible and how to make it more private and secure. And those are great points, but we still face a lot of challenges. Like if we don't have a large compute, how do we contribute? How do we benefit from this kind of system? How do we get rewards using crypto? So this kind of challenges we're actively tackling every day, and how to make it more private, more secure than OpenAI. And we're using a combination of solutions of TE and ZK and split learning. Those are something we're trying to address in the domain of distributed inference and training in blockchain and AI.
Let's get the audience a little bit excited through some of the dangers of AI if left unchecked, and how Web3 might provide certain solutions to specific use cases. There are a couple, I think that are hanging out there. When someone released an image of the Pentagon on fire, the stock market dropped $500 billion. S&P dropped billions of dollars. When people don't know what data sets are in the data pipeline, no enterprise can adopt it and feel certain that they aren't infringing on copyrighted data. When when the data pipeline is as opaque and as closed as it is, we haven't even seen the era of cheap ChatGPT. People that are basically plugging into suboptimal models and faking the power of how good they are. So that kind of covers, verified inference, data verification, as well as, sort of just authenticity of what you're using when you're connecting all these different systems together. I don't know if you guys have any, specific anecdotes or some use cases like that, or just a little framing on, how your projects, might help combat some of these challenges, but I'd love to hear that.
Yeah, very good points, and I think they very much build on that. I think we are right now at a pivotal point in history where we are about to see a completely new age of intelligence, right? And what we have seen 1.5 years ago is the beginning of that, but we are now at the beginning of the next step of that, I think, with personalized AI, right? Essentially models that know you in and out, that have been trained on some of the most sensitive data that makes you, right? That includes things like text messages, that includes things like health records, that includes things like fitness data. Anything you can think of that makes you will be fed into those models to train a personalized version of you, which is amazing because in everyday life, it can make a lot of things better for you, a lot of things more efficient for you, a lot of things more productive for you. But at the same time, we have to ask the question, what are we willing to sacrifice to get there, right? And if that means that we have to feed all that sensitive, important information to a single company, or to a few single companies, then that is not a feature that I hope we are moving into, because I think that is inherently a dangerous feature to be in. That is on the personalized AI on the retail user side, where I believe that privacy-enhancing technologies, like I touched on initially, multi-party computation, FHE, and the likes, will be extremely important technologies to protect us from a feature like that, where we have to sacrifice privacy and security to get those personalized agents, those personalized co-processors, so to say, into our lives. On the enterprise side, it is already a burning problem, right? So I don't know how familiar people are here, but 75% of companies are planning to ban ChatGPT or have done so already, because every time they send a prompt to the model providers, they possibly send very sensitive information. They send IP data, they send strategies, ideas, whatever it is. So now they bring everything in-house, try to train their own models, but obviously they're not on the cutting edge, and it's not their expertise, and it's also very expensive. So having privacy-enhancing technologies, I think, will be a critical part to get us to that future where retail users can have their personal agents, but in a privacy-preserving manner. And likewise, companies can continue to use API solutions, proprietary API solutions, without sacrificing privacy and confidential information. So that's that part. I think another one you touched on is authenticity. I don't know how many people still remember the picture of the Pope. That was a great example. But way more than that, every day we read the news, we read articles, we see pictures, we see a golden retriever in the snow that looks more real than any time before. And we don't know, is that real or is that AI generated, right? And we will need a system, a standard that ensures that content that's generated by somebody is digitally verifiable, is timestamped on chain, so we can actually always look back and when that was created to really ensure who the creator of content is and was going forward. Otherwise, we'll live in an age where it will be almost impossible to verify what's real, what's not real, and who the creators are and who the creators are not, basically.
Yeah, another kind of danger, I guess, potentially is the other side of like, more we can reliant on LLMs is like this potential for them to like hallucinate. And if we want to rely on them for on-chain kind of transaction-based things, then it becomes this kind of potentially open kind of endpoint for LLMs to start transacting in this like event-based system. But I think the cool side of this, and at least like what we're researching a lot, is like we have this really structured smart contract architecture with this potentially open-ended intent-based LLM system. But what that actually opens up is actually super interesting, where currently like the gateway of Web3 is like a wallet. And so you have to actually assign permissions, sign signatures, transactions, all through this wallet. But an LLM actually through natural language actually lets you access all of Web3 the same way a browser did for the internet, right? And so while it opens up these kind of dangers and these hallucinations that are potential, it actually opens this entirely new design landscape for actually interacting with this blockchain and actually engaging with it.
I think, another example I have been experiencing, like working with healthcare data, is that the data is actually very private, so we cannot transmit easily from one institution to another. And the model can be easily contaminated or attacked if someone is dishonest and they use some contaminated data to fine-tune the model. The model will be contaminated and it cannot be usable after training on those kind of data. So I think this kind of end-to-end encryption of data and model is very important, and that's what we try to achieve at Nesa with all these hardware and software solutions like TE and ZK and Spectral learning. So we make sure that no data is leaked and all the models are honest, and it cannot be easily adversarially attacked or cannot be contaminated with different kinds of poisonous data. Yeah.
I think we talked a lot about like the technical solutions to authenticity and to privacy and things like that, but one of the, I guess, most interesting things about Web3 is it's technological, but it's also social. So there's like an ideology that comes with Web3 as well. And I think that ideology around trust is one of the most important things. We've become used to, in recent history as humans, being able to trust like the images that we see and things like that. But if you look at how we interact with the world in general, it's very probabilistic. Like you will see something happen outside in the real world and you'll think that you know the reasons for it happening, but at the end of the day, you're making constant judgments in your brain as to why that happened, what's behind it, whether it did actually happen, etc. We exist in this probabilistic world, and I think it's easy for us to forget that the imperative world that we created with technology over the past few decades essentially isn't necessarily the norm. It's just something that we got used to. And actually, I think the new wave of machine learning and AI is showing us that probabilistic world is easier to interact with, it's easier to process and kind of devise new inferences from, etc. And what we're seeing now is machine learning models doing that as well as people, whereas before we thought it was just people and technology was just always exactly what it said it was. Realistically, I think we have to lean into that as society. We just have to accept that the world is probabilistic. It's not always imperative. One of the clearest examples of this, like completely outside of Web3 in the machine learning space, is self-driving cars, where you look at the performance statistics of self-driving cars, and I think they're safer than human drivers. Statistically, but we don't like them because we don't know why they make decisions and things like that. But if we're to progress, if we're to embrace technologies which are objectively better for the world, we need to understand that some of them will operate probabilistically, and machine learning models do operate like that. So I think there's a lot of technical stuff we can do to establish trust and to do it to have trust in a way that doesn't rely on institutions. It relies on pure technology, but at the same time, we need to also trust in the probabilistic outcomes and say we don't have to know exactly how this happened. We trust the full chain that came before it of provenance of data and model training, etc., which means that model made a decision similar to how a human made a decision. We don't judge people for making decisions that weren't exactly auditable. We just accept that they make those decisions, and I think we'll have to accept the same for models. That does mean at some point in the future we're going to have a bit of a kind of social clash, I guess, on what are the rights of models. When they get more and more like people, we're going to have to decide whether we as society are going to be able to see them like people, or whether we're going to try and make them be like the imperative machines that we've seen before. I think if we do that latter, we'll just hold back human progress, and eventually, inevitably, we'll have to see them as the former.
I'm really relying on you guys not to live in a dystopia where the rest of time is based on the past 20 years of data, and AI starts, reinforcing its own learning based on other AI, and we just live in a big loop. So hopefully, if true, and how Web3 can help, it should add efficiency, half efficiency, and it should add openness, and the openness will allow for the innovation to flourish and to continue to, effectively find new paths of doing things versus not understanding, sort of what's going on. So we're starting to see early tea leaves of adoption of AI in general, and I think as soon as OpenAI stopped being so open and started realizing that there's a lot of money at stake here, we saw them, quickly, turn to trying to safeguard some of the innovation that they've created. But what evidence are you guys seeing in terms of a change in heart from a lot of the Web2 AI community towards, what Web3 could help them with? And what type of, if at all, evidence are you seeing from developers or applications that are starting to tinker with your systems or starting to adopt, some of these technologies that you guys are focused on building?
I think the clearest wave from my perspective is just the open source AI ecosystem. I think there's a lot of developers in machine learning and AI. Some of them are at places like OpenAI, but a lot of them aren't, and they want to build the same models. And I was in this position back when I was doing research. I had the designs for the systems I wanted to build. I had access to all of the data, but I couldn't go and build those systems because I didn't have 3,000 GPUs in a data center, and that was just incredibly frustrating. I think a lot of people in that position in the past have then taken that path to, okay, I guess I have to go to OpenAI or Google or DeepMind or Meta or one of these places because that's the only place that I can do it. And then in recent history, we've seen people actually just band together and say, hey, if there's like 100 of us, maybe we can just get the resources between us and we don't need to go to one of these big giants and build it there. And I think that's really exciting. And probably the most obvious thing to everybody in Web3 is that's an amazing problem to solve with Web3. Like that coordination problem of those people, being able to financialize that system, those people, if each individual puts in a small amount of money, they can pool it together, they can buy those resources. How can they do that and trust each other when it's such a big group? Web3 solves that. So I think we're starting to see that happen. There's a huge barrier, which is the perception of Web3 from the traditional tech world. I think it's gone through a difficult time. The financialization aspect is fantastic, but it also means that the headlines that you see when you think about the financialization are pretty damaging, I think. We probably all admit that over the past few years. Most people view that as a hiccup in the start of a new technology, essentially. But I do think Web3 needs to get through that perception issue and show the real value of the technology underneath and show the coordination that can happen and that you can have these groups of people just come together and gather the resources to compete with people like OpenAI. And that's one of the things we think about the most at Gensyn is we're building a compute network that anyone can use. The idea is that anyone can provide the compute and anyone can access it. It's not just these big players. And more we'll see the big players go after regulatory capture. Maybe they have some real fears behind that. Maybe if you're a cynic, you think they're just trying to cement their position. But it shouldn't matter. If we build the technology right, nobody will be able to do that. That capture is rendered impossible. And I think that's the most exciting thing about Web3 when applied to those resources under AI.
Yeah, I would agree with that. So I think that the hardware component, as I said initially, is a big problem. It is very hard for developers to access the resources they need to train models, to fine-tune models, to run inference on that. And given that it's very concentrated right now, there's a significant economic surplus that's generated, obviously, with a fee. The profit, I think gross profit margin, I don't know on top of my head, but is 60% with the likes of AWS on their GPUs. And those costs can be reduced dramatically. Potentially for a decentralized marketplace. There are also centralized companies that offer those GPU marketplaces, so it remains to be seen whether crypto incentives will win against the centralized players in providing those marketplaces, but more broadly the idea of providing access to resources that are underutilized is, I think, a big win. Now, specifically in our project, what I'm getting excited about is the ability to start sharing data across users and across enterprises, which is something that is very, very difficult to do, to almost impossible to do, given the regulatory constraints and the trust limitations, of course, that companies are subject to. It is just not really a possibility for a hospital to share data with other hospitals unless they go through a very cumbersome process, which is first of all, very inefficient and also inaccurate usually when processes are implemented to do that. So now, if you have a platform that can actually enable computation on hidden data, on blind data, so to say, and you can still run compute on that, run machine learning algorithms on that, you could start to find new patterns, start to find new discoveries that otherwise are very hard to find because you have not the same amount of data available to train models and then to run inference on those models. So that's certainly what I'm getting excited about, particularly on the sort of, heavy regulation dominated industries. That is healthcare, for instance, but many others as well. And then, as I said, on the transformer side, on the LLM side, I think that we need to develop a future where people can actually use those models without having to sacrifice security and privacy by running those models with single providers. And on the enterprise side, we need to develop API solutions so that people don't have to bring everything in-house, as they've done previous to the cloud development 15 years ago. And we can only do that if we ensure that they use cloud solutions which are actually private and secure, such that they can protect their confidential information. So that's what people get excited about, the ability to have private input and the private model, where the model provider can actually keep their model secret so they can protect their intellectual property, but at the same time, the user using the model keeps the data private. So private input, private model, that is something that the likes of multi-party computation, FHE could unlock, and that is, I think, really exciting.
Yeah, I think the coordination design that Ben mentioned is actually really cool and is being applied in a great way to like hardware and GPU resources. What I think that leads to is actually really strong incentive design for collective ownership. And so where we can have collective ownership around these GPUs and utility around them, you could actually apply the same heuristics to model ownership and inferences, where you have these open source models, could be actually funded and crowdsourced, and actually start to gain revenue from these models and training that you actually back. Which then actually leads to verifiability of other models and use cases. I think right now there's been a big narrative around verifying, I think it was the Twitter algo. Are people getting blacklisted or shadow banned? And right now I don't know if there's enough of a crossover of people that really care, but eventually as models and AI start to cross over into really critical pieces like healthcare, then you actually need this verifiability, right? And so this kind of mechanism design around coordination and incentives is actually going to play a really strong role around disincentivizing harmful behavior.
Yeah, so I just want to add, I think people are definitely very excited about what we're doing. We're going to launch the testnet in 2 weeks. And we have written a research paper about how we shard the large models, and so people, even with small GPU, CPU, can access it and can train an inference on it. Dynamic sharding, very interesting, and also the security and privacy part in our research paper. And I think definitely encourage people to take a look at it. And so I think we also build a lot of dApps ourselves on the layer 1 infrastructure, something like character AI, people can easily transmit our own personal information without worrying about security and privacy, and run the inference and get response back and just chat and message them. So I think there's a lot of interest and enthusiasm for what we're coming in Nesa.
Excellent. Well, I think why the AI Web2 world has taken off, it's still very nascent in Web3, and some of that has to do with the prerequisite expertise, to build in Web3 AI, and really it's this Venn diagram of understanding AI, understanding Web3, and understanding some of the emerging, cryptographic components that are exceptionally important to verification and cost reduction for verification, such as zero-knowledge proofs, FHE, and other emerging cryptographic primitives. What do you guys think? Are these technologies important to the Web3 AI mission? Do you think that crypto has helped them advance faster than they would have had crypto not existed? How do you guys leverage things like ZK?
Yeah, I think that's a good point. I think definitely ZK and homomorphic encryption has been advanced by crypto in recent years. But I think we have done a lot of research at Nesa, and we think that it's just not there yet. That ZK for large models and homomorphic encryption for large models is just very slow and a lot of latency and computationally very heavy. So that's why we'll have to design novel approaches for ZK, partial ZK, just do ZK proof on a few layers and a few kernels that are easily verifiable and in a short amount of time. So that's what we're doing, trying right now with this kind of new ZK in our system, and also some kind of split learning that can put data in the client side as input, output a few layers, and add some differential privacy noise to before embedding sent to the network, so that it's more secure and can be decoded later. So this kind of new technology of split learning and differential privacy plus partial ZK is what we're doing on software system, and TE as a hardware side is also making it more secure. So, but I agree, ZK and homomorphic encryption definitely something need to be investigated and need to be studied, but it's just not there yet.
And maybe someone could also just explain ZK for the audience too. That's helpful.
Sure. I mean, when we talk about ZK these days in crypto, what we actually talk about primarily is verifiable compute. So ZK can be used for privacy, but actually what it is used primarily for right now these days is scalability, right? For blockchains with ZK rollups. And also when we talk about ZKML, it's basically verifiable compute. So that means that you have a prover, you have a verifier, they run the model, and then they prove they've actually run the model that they claim to have run, right? Which is very important, given that crypto is built to be a trustless / trust minimized system, right? A credibly neutral, decentralized, trustless system. and you need to establish the one way or the other that off-chain compute has actually happened with the right model, with the right data. So that is a key part. So whenever there is public input and a public model, ZKML is very interesting. Whenever there is private data, private model, then we tap into MPC and FHE, right? So those are different use cases for different privacy enhancing technologies. The reality is there is not one privacy enhancing technologies that will win over others. It's the combination, the collective of them that will win. There are different use cases, different requirements, different security assumptions, different performance assumptions. And for those different things, you will need different coordination among those different privacy enhancing technologies, something which we are building at Nillion, where we're aiming to essentially coordinate effectively among different primitives across privacy enhancing technologies. So they are extremely critical because crypto is built to be, as I said, a trustless, trust-minimized system, a credibly neutral system, a decentralized system. And for that, we have to verify, compute, and enable privacy for the computation of models.
Yeah, another side that we're interested in around these proving systems is actually around like agent-to-agent interactions, where you have an on-chain agent that has access to its own wallet, its own private keys, it's transacting on your behalf. But what happens when it starts to interact with other agents? The same way a human does, or at least when I do, I double, triple check the URL for when I'm trading on a DEX or like Uniswap or CowSwap, that I'm not on a phishing site. But an agent actually needs that same validity and verification when they're transacting with another contract. And so these proving systems could become quite critical in a very kind of different implementation. And so kind of being creative around these different proving systems to create this underlying kind of validation or integrity layer is actually important when there's autonomous agents transacting with each other on-chain.
I think I strongly agree with the point Lukas was making around these privacy-preserving technologies, whatever you kind of want to class them as. They're all separate technologies, all with specific places to be applied. And I think one thing that's really interesting is they're all moving out of research and into application. And everything typically, when it goes through that phase, goes through this wave of excitement where people start to see, hey, I can see what's going to be possible when this happens. But then there's a dip because they're really hard to actually build. So we've proved from the research perspective that these things are possible that we didn't think were possible before. I think like ZK Proofs is a great example where most people, if you told them, hey, I can take this computation, I can prove to you that it definitely happened in like an absolutely tiny fraction of the computation, that's pretty amazing. It doesn't seem like it should be possible to be able to do that. So once we've sort of proved that, everyone gets excited, but the reality is they're just really hard to build. They're really hard to pick which ones you should use, and then putting them into production is difficult. You have to find the right use case, you have to apply the right technology to the right use case. Some of them are very narrow, some of them have configurable parameters that are just really hard to choose. So we're in this sort of phase now where we've seen a lot of these things exist and they're possible and they unlock amazing futures, but we need to double down and build them properly. And that's something we think about all the time at Gensyn. We see a lot of kind of talk about the technologies and then we see the reality of they are really hard to apply to certain challenges. We think the most about verification of machine learning training tasks, so absolutely enormous computations off-chain that need to be proved on-chain, and that isn't just throwing ZK at it, it's a combination of ZK with multi-party computation, with split learning, with game theory, with probabilistic checks, auditing, all of these things to actually make an efficient system that works. Maybe one day we can do a ZK proof of a machine learning training job, but it's not going to be anytime too soon.
Yeah, I want to maybe just build on the last point with some numbers around what we have seen. So on the ZK side, in 2021, I think there was a classification MNIST training proof that was generated in a pretty strong period of time. Then a year later, we have seen ImageNet models with which one could generate proofs. So the speed of improvement is incredible, right? And likewise on the MPC and functional secret sharing side, Microsoft Sigma released a paper in 23 in August where they were using functional secret sharing to essentially run inference on GPT-2, GPT-2 having around 1.5 billion parameters, and they were able to do that in basically 1 second. I think they were able to generate a token. Now, this is clearly showing how fast the improvement is, right, in this space. And we actually, on the Nillion side, have found further significant improvements on the Microsoft paper where we're using discrete wavelength transformation for the nonlinear part of the activation function in these transform models, which will further accelerate the performance in running those models. And particularly if you look at Apple talking about it last week, or I think this week, releasing some small models soon, which they claim to be potentially, or other people claim to be potentially as performant as some of the latest GPT models, and they sit in the 2-3 billion parameter size, then all of a sudden, running those models with privacy-preserving technologies like MPC functional secret sharing, as I said, becomes potentially a reality really soon. Now, obviously, this is early days, and there will need to be further improvements, hardware improvements, latency improvements, cryptography improvements. But it's exciting to see, to me, both on the CK side and on the MPC side, in which direction we're going.
Sorry, just wanted to jump in on that. I think it's really important to flag basically what you're just saying, the progress from the AI space as well, because these the two spaces progressing in tandem is what makes it so exciting. Like you say, we don't necessarily have to prove this absolutely enormous transformer model, because at the same time, the ML space is saying, hey, we did this huge transformer model, it showed what was possible, and then, yeah, we can compress those models down, we can make newer models. So you can't just focus on one side of these two technologies, you have to be able to focus on both. And I think that's what makes it difficult, because there's few people in the world that exist at that intersection. And it's hard to find people who can understand, hey, ZKML works in this way, but ML is changing constantly as well. We're like, they're two technologies that are progressing ridiculously fast, like you said.
Well, I think we covered a lot today, and it's pretty clear to me that there's a real case for verified compute, but right now we're kind of struggling with some of the challenges of making it more efficient, so that it can be used in production, so that it can become competitive in cost. But while we do that, last quick one, we don't have much time left, so we'll just keep it brief. Let's talk about the call to action. You have an amazing university here, you have top regulators in the room, you have probably a lot of supporters, probably a couple skeptics, and crypto is really a ground up movement. It's being built by people who are excited about the promise of this safer and more exciting adoption and use cases. But at the same time, it needs support. So I definitely think Harvard needs to spin up a GPU farm dedicated to Gensyn. But what can what can you guys ask people for that would sort of be helpful as we think about support here?
I think two things from my side for people building in the space or thinking of building in the space. One, focus on the technology. Don't kind of get distracted by a lot of the financial stuff that happens in the Web3 space. Just focus on, look, these are enabling technologies that unlock an amazing future. Focus on those things. And then the second piece, accept that they are hard and they should be done right. It's very easy to cut corners, especially in the Web3 space. There's a lot of money around, there's a lot of hype around. You can sort of pretend that you've got the solution and launch something and then hope that you'll do it behind the scenes. We don't think that's the right approach. We think the right approach is to focus on the technology and think about, are you actually building something right that provides real value, that actually solves a problem in the world? I think if more and more people do that, we'll move AI and Web3 away from being these kind of sort of hyped things into just being the next enabling technologies, which is what they are.
Yeah, I mean, I will echo that. So I think what's critical is to think about the future we all want to live in, right? What is the future we want to live in 5, 10 years from now? Is it a future where we have those personalized models and we have to trust one company or two companies with everything about us? Or is it a future where we want to come together, collaborate, and build the future of privacy-preserving technologies which are composable, which are open, which are globally accessible, and where open global participation is at the center. So focusing on technology that will shape the future, that will create a new computing paradigm, I think is super exciting. And building end applications on top of those technologies that are currently being built out that ultimately touch the end user is obviously what I would recommend everyone, because it is a future that we all have to work towards, and it can only work if we come together. Because we will not be able to do this ourselves, we will not be able to do it in just this room. We have to convince people out there that there needs to be a better future than a future where we have to trust one actor. There is a need for decentralization, there is a need for trust mitigation, and that can only work if we come together.
Yeah, I think generally there's a lot of focus around like building infra in Web3, and I think there's like a lack of like consumer products. Most of the use cases are all around like trading, stable coins, or staking your ETH. And so, what I want to encourage people to do is actually start using on-chain products and actually start understanding the drawbacks of the UX of wallets, and then what can actually like AI and ML actually advance here, right? So is it like intent-based systems? Is it abstracting a wallet clunkiness? There's a lot of improvements that we can make. I think like the underlying infra is actually definitely being built. There's a lot of focus on it, but an underappreciated side is actually getting to that consumer experience that we could actually enable.
Yeah, from Nesa's perspective, I think definitely we encourage people to embrace the new technology and build on top of it, especially we're coming out of stealth and we're having thousands of models that you can run and you can train and you can inference. So I think it's a very good time to build on top of the technologies and just don't get too comfortable with OpenAI and Anthropic, with AWS GCP, because who knows what they're going to do someday. So just embrace this kind of decentralized inference and also put necessary regulation in place so that we can better advance.
Well, thank you all for being patient and listening, and thank you to the panel. Amazing insights. So.